Good. Well, what time is it for you? Hey, QED coders. This is Michael. I would usually say good afternoon to Jan. It's afternoon in France, where he is. Wherever you are, welcome. This is a State of Jinaga recording. Making sure that I've got the levels correct. All right, make sure that you can hear me properly. A little bit louder. There we go. Today we are going to be talking about modeling. Modeling is a great way to understand your domain and then to capture that understanding in some documentation and generate some code that you can then use in your application. So I'm going to begin with a little project that I like to call Festify. Let's do a screen share so that you can see Festify, and anybody who might be joining the conversation later will be able to just join on in. All right. So in fact, if somebody joins, I will do the screen share, but this way we get to have a little bit better experience. So there we go. Boom. Okay. All right, the Festify application is an example application that I use in lots of different places. This is what I use in order to demonstrate distributed systems, entity framework. It's a simple application that has just enough complexity that it demonstrates a lot of good patterns. What we've got here is a wireframe or a storyboard that shows how the Festify application flows. You start here with the index of all of the different venues. So we've got a couple of example venues in there. And then from here, you can navigate to any of these 4 screens. You can click the Create New button in order to create a new venue. You can edit, you can view the details, or you can delete. So if we click on the Create button, then we've got this screen where we can enter some details about a venue, create it. Notice that's navigation. This button is the action. We're going to be interested in the actions. You could also go to the details of a particular venue, and then from here, you can navigate to Edit, where we have another action button. You can save those edits. And then finally, you can navigate to the Delete screen, where now you get to confirm that you want to delete, and now you can take the action of delete. So that acts as the confirmation page. So that's managing venues. Then in addition to that, you can manage acts. So we've got different acts that we want to promote through our Festify promotion system. And then from here, you've got the same things. You can create, edit, go to details, go to delete. These should probably be links instead of buttons because they are not actions, they are navigations. Navigate to the create screen. There you can take the create action, details, or edit. Same kind of things. There's the actions. Now from the details screen of the act, you get a list of shows, and this continues the pattern. From here, you can create a new show, or you can delete a show. There is no edit capability here, and there are no details because all the information is shown here. So you just have create and delete. And so the first part of historical modeling is that we want to capture some actions. We want to know when the actions have occurred. You can see the work that I had done previously. You can watch the recording of that video that I did at the .NET, the North Dallas Developers Association. That'll show you that process. But just to reiterate it really quickly, we added some orange stickies that captured the events that occur when I want to create a venue. So the venue is created at this point. And then here the venue is edited at this point. And over here, venue deleted. So we start with the same process that you might already be familiar with as event storming. So event storming is a workshop where you can get all of the stakeholders together. They can understand the process in a much more precise way, and then they can document all of the different events that occur along that process, capturing the user journey. This then can feed into event storming, where you use these events. Event storming can feed into event sourcing, where you use these events as the source of truth. Here we're going to deviate. Instead of using this to capture the events for an event-sourced application, we're going to use these instead as historical facts. And that leads us now to this diagram here. After you iterate on that diagram a little bit, you can bring all of these different events down together and create these predecessor and successor relationships. So what we called up here, the venue created event, has become the venue fact. It's just the fact of the existence of the venue. And so that must exist before you can edit the venue. You can edit the venue's name, you can edit the venue's location. Those are two different concepts within the venue that you might choose to edit. So when we take a look here, we could capture all of these properties as one domain event. But some of them kind of go together. You can take the city and the time zone, latitude and longitude, and you can say that really describes the event's location. That shouldn't change nearly as frequently or at the same times as the venue name. The venue name tends to change whenever a new corporation decides to purchase that venue. I live in Dallas. I used to go to the Starplex back in high school, and it's had several different names since then. Still a great venue. I don't know what it's called these days. The name has changed, the location has not. So, probably the Coca-Cola Starplex? I don't know. So, at least at some point it was called that. So you can capture different domain events based on what the user does with this form. If they edit the location, capture that. If they edit the name, then just capture that. Don't capture the location if it hasn't changed. So that is the process that we go through in order to capture all the things that can happen with a venue. It can then be deleted. That deletion can be restored. The similar things can happen on the act. You can change the title, the image, and you can delete the act. And then, with a show, we only had two actions that could occur. You could create a new show, or you could delete a show. And these properties are immutable. There is no edit. So therefore, we will keep those properties on the show itself, and we won't have a mutation. So this is the first process that you'll want to go through, where you work with your stakeholders to capture this model. From here, we want to get into some code. And you'll find instructions right here on Jinaga.net. So you go to Jinaga.net, go to Docs, and right here on the side you'll find modeling. So there are a few prerequisites. You want Visual Studio Code, you want .NET 8, you want the Polyglot Notebooks extension, and you want GraphViz. So make sure that all of these things are installed, and now you can use Polyglot Notebooks in order to model in code in order to capture this model that we just did on the whiteboard. So let's flip over to Visual Studio Code and let's create our first notebook. So following these instructions, we'll go with setting up your notebook. We want to create a blank notebook, and we want to put these two code blocks into it. So we're going to Control-Shift-B, use Polyglot Notebook, create new blank notebook, and we want the file format of IPYNB. Then we want C# as our language, and then we can copy these two code blocks into it. You can see that imports all of the Jinaga NuGet packages, and then this one, we hit the plus code here. This one sets up all of the namespaces. So now we have a nice environment in which we can call Jinaga code. I'm not going to do that right here in this notebook, though. I am going to create a new folder in here that I call documentation. And then inside of documentation, I'm going to save this as I want to create one more folder in here. I'm going to call this 0 setup. And then inside of here, I'm going to save this as packages.ipynb. Hit the run all again, and we can see that show up. We are setting up a structure, and this is giving us the instructions on how to get that structure started. So the next part of the structure that we want to set up is the Jinaga client. So let's create another new notebook, IPYNB, C#, and we want to capture this and this. So now when we run that, first I have to save it as, this is going to be client.ipynb. All right, so now that it's saved there, it knows what folder it's in, and it can import going back out and then into the 0-setup folder, so something else that's in setup, the packages IPYNB. So you can see that it has run that, it's done that import, which appears in packages IPYNB, and then here it's created a new Jinaga client for us. And we're going to use this client in order to set up various scenarios. But these are our setup steps. This is what's going to give us our modeling environment. So now that we've got those, we can move on to the next part, which is models. So I create a folder called 1-models. By the way, if you run into any issues, these buttons are your friends. And if those are not good enough, then you can reload the entire window. Let's see if we actually run into those problems. So this is the structure that we're setting up. We've got 0 setup, we've got our packages and our clients, and we are creating our models now. You'll see that the models only refer to the packages. It's not until we get into scenarios that we bring in the client. And this allows us to limit the number of Jinaga clients that we're importing. And if we've got some scenarios that have to do with some integration between two models, we can model that appropriately. This operations folder we'll get to in a future video, but that is really cool. Okay, let's continue on. Now here on the site, it walks through an example of performing some modeling using some using the blog example. I'm going to be using Festify. So let me go into models here. I'm going to create a brand new notebook again, and this one I'm going to start out with. It's bang pound import, and then we go out to 0 setup, and I'm just pulling in packages. IPYNV. Okay, so I've got those. Oh, I have to save it before I can do that. Here is the models, and we're going to be talking about Festify. So the whole model is going to be in this one file. As opposed to, I could have one model that's all about acts, another model that's all about shows. That might be interesting to, you know what, let's go ahead and do that. That would be really interesting to demonstrate some of the cool patterns that you can have here. So this one is going to be about venues. Okay, so I've got my venues. Run all. Run all is not working for me anymore. So let's restart the kernel and run all again. That's not working either. So this is how you restart everything. So I'm going to go to Developer, Reload Window. And now everything should be set back up. Run all. Okay, it's able to do the import. There we go. Let's get to modeling. Let's go back to our window here, and we've got the venue fact at the very top. Okay, let's create a venue fact. So in code, I'm going to do fact type, and we're going to have Festify is the name of the application, and venue is the name of the entity. So that's the naming convention that I like to use, application.entity, to get things started. And now all of these facts are represented as records. So I'm going to say public record Festify, or venue. And then the parameters are the fields, the things that distinguish this particular fact from other facts. So in order to distinguish one venue from another, we will just use a GUID. So this is going to be venue GUID. And that is going to be our venue fact. Okay. Now let's record some things like this that we can delete and we can restore a venue. So let's treat this as an entity now. Entities can be deleted and restored. So fact type festify.venue.delete. So this is a fact recording that the venue has been deleted. So we're going to say public record venue delete. And now what distinguishes this from other deletions? Well, the venue that we're trying to delete. That is what we will need to know when we issue this fact. Now, if you've seen me do other modeling demonstrations, you'll know that I've made a couple of mistakes here. That's fine. They are deliberate. We're going to come back and fix them. That's part of the whole modeling iterative process. So once you have deleted a venue, you do want to be able to restore it. So let's record another fact. Fact type of Festify venue restore. And what makes a venue restore unique? Well, it's which venue delete we are talking about. So we're restoring the one that was deleted with this delete. Now from this, I can do fact renderer, or renderer, R-E-N-D-E-R, render types. So I can render out all of the types that I've just defined here. I'm going to just say venue restore, because venue restore refers back to all the others, and so it includes the entire graph. When I do that, then I get this nice little graph that shows me what is required in order for me to record a venue restore. So the whole graph. of the venue, delete, and the restore. So that kind of mirrors this structure that we've got here. And that's what we're going to do in order to set up the entire model in code. Okay, so now we've got our venue. We don't yet have the name or the location. So let's zoom out here and talk about the edits so that we can talk about the name and the location. Name is just the name American Airlines Center. So when we go back to code, how do we record the venue name? So it's fact type festify venue. So we start with the application and the entity, and now we've got here we used the action on that entity, delete and restore. In this case, we're going to use the property that we're editing. So name. That is the fact of a change to the venue name. So we'll do a public record venue name. And so we need to know which venue we're talking about. Venue. And we need to know what is the new value of that name. So again, deliberately making a mistake here, but this is how you might get started. Okay, let's take a look at that. We're going to go back to the renderer, and we're going to render types, type of venue name, and we can see that is the little part of the model that we're talking about here. If I wanted to show the whole model, I can do type of venue restore, and that brings in the other part of the model as well. So I can see there's the delete path, there's the changing the venue name path. And I can see, since they're on different paths, they're not causally related to one another. I can delete before or after changing the venue's name. But for right now, let's go ahead and focus on this part of the model. Now, at this point, I want to go ahead and exercise this model. I want to see how it behaves under different scenarios. And so I'm going to come back up to documentation and create a new folder called 2-scenarios. And this is where I can start to create different types of these facts. So let me create a brand new polyglot notebook of type IPYNB, C#, and I'm going to import, and this time I want to import from the model. So let's go out and then back into models, and then venues.ipynb. Now you might be thinking, why not just do /? This is because of something that Jan discovered. We need to have something that's going to be consistent no matter which notebook you're starting from. It uses the current working directory. It doesn't use the model, the notebook folder. So this way, everything's consistent and it always goes back up to the top level. It also has the nice benefit of documenting where you're getting this information. So we're bringing in the venue model, but we also want to bring in the Jinaga client. So I'm going to go back to setup, and I'm going to go to client, IPYNB. Let me bring in both of those things after I save. Thank you. So we're going to go back to here, but go into scenarios, and I'm going to call this venue edit. So this is the scenario of the user editing venues. So when I run those imports, you can see it displays the output of the prior notebooks. And in fact, if I had some text in here, which I do recommend that as you're modeling, you keep track of things with some markdown here. So we can have structure about the user can create, delete, and restore venues. Boom. And then describe what's happening here. Okay, so that way when we run this import, now we can see that that text there as well. This gives us a quick look at what the model is. So when I write some code here, I can see this is what we're looking at. You can start to see here the reason for structuring the imports. We've installed the packages here in order to bring in venues.ipynb, and then we've installed the packages again in order to create the Jinaga client. So it's fine to install the same packages twice in the same workspace, but you definitely want to control the Jinaga client and only do that once. And that's the reason for this particular structure. So let's go ahead and set up some scenarios. So the first thing that I want to do is create American Airlines Center. And so that's going to be we're going to await Jinaga client.fact. And this is going to allow us to create a new fact within the model and record it in the Jinaga client. So we're going to have a new venue. And the parameter to the venue, which flashed on the screen real quick. Oh, it's Venu. Used to work for a man named Venu. There we go. Is the venue GUID. So we're going to say GUID dot new GUID. And now we have our new venue. How do we know that this is the American Airlines Center? Well, there's nothing in here that says it. It's just a GUID. So what we have to do here is create the venue name in order to say that. So I'll say the name is equal to await Jinaga client.fact new venue name, and we say this is the venue, AA Center, and this is the name, American Airlines Center. Okay. Now that I've got those facts in the system, I can create a diagram of those facts. And so I use Jinaga client, and I call .render facts. Not render types, but render facts. I don't know why it appears twice there. Probably because I installed the packages twice. But then from here, I can render the AA name fact, because I know that it already identifies a center, so it's going to include that in the graph. And so there we have the venue GUID and the venue name. All right, so we have set up a scenario. Now I want to exercise that scenario. So I want to show the different things that that could happen. So let's first talk about deleting a venue. Well, American Airlines Center still exists, but there's another venue here in the Dallas-Fort Worth area. So it is in Dallas, or it was. This is the Bronco Bowl. So we're going to await Jinaga client.fact, and we're going to create a new venue. GUID.new GUID. And if we spell everything correctly, then we will have a brand new venue. This time, it's going to be the Bronco Bowl. It's going to come up with a different GUID than the American Airlines Center. So let's go ahead and name it var Bronco Bowl name. Let's make sure that that GitHub Copilot can help us out here. So that is going to be a new venue name called Bronco Bowl. Okay, so what do we want to do? Let's go ahead and render that out and see that structure. just what you would expect. Different GUID, different name, it's a different venue. But that venue no longer exists. So what I want to do is, sadly, I want to close the Bronco Bowl. So I'm going to create a new fact called of type venue delete, and it's going to delete the Bronco Bowl. Goodbye, Bronco Bowl. Venue delete. Boom. It's gone. Well, is it really gone? If I were to try to render things out, we can see, no, it's still there. We just have a new fact hanging off here that says it should be deleted. So what do we do with that fact? Well, we need to be able to list all of our venues, right? And so that fact is supposed to tell us to remove it from the list. So how am I going to get a list of all of the facts? In order to get a list of things, you need some place to start. That's kind of a hard and fast rule of Jinaga. It's not like in SQL where you can just select star from a certain table and just get everything in that table. The reason is that Jinaga is intended to be a distributed application, and it's supposed to a distributed framework, and it's supposed to integrate with other locations. And so there is no all things in a particular type, in a particular table, because that's the whole world. The whole world's out there, and it can create things all it wants to. We're not going to go out to the whole world and grab everything. We need a starting point. And so that starting point for this kind of application is going to be the environment, which application deployment are we actually talking about? The production environment, the development environment, which company owns that environment, all that stuff. So that's our first clue that we need to change the model a little bit. Having a venue that's just identified by the venue GUID, not quite enough. We need to first have a fact type of specify.environment. And so this is going to be a record named environment, and GitHub Copilot recommended here environment name. That may be sufficient if we knew that somebody else couldn't name their environment the same thing. So let's start with that, but we're going to see what the problems are there. So now the venue belongs to an environment, so I'm going to say environment. Modify the model here. And so now when I run this, I'll see that now environment is at the top of the chain. And then furthermore, when I edit, the environment is there at the top of the chain. So that's my new venues collection. And so if I save that and then run this, I should get some errors because I can't create a venue with just the venue GUID. I have to first create the environment. Let me create one of these first. So I'm going to await Jinaga client dot fact, and I want a new environment with a particular name. I'm going to call it test. So let's go ahead and create the environment, and now I can use that here. That will allow me to create this venue, and we can see now this venue, American Airlines Center, belongs to that test environment, and so does the Bronco Bowl. Boom. And then when I delete the Bronco Bowl, then I'm deleting it and it used to be in this environment. Now I've got a place to start. Now I can start with that environment, and I can say, show me all of the venues in this environment. So that gives me a context, a boundary, in order to run that query. So I'm not asking for the world. I'm only asking for your half. If you know who that is, leave a comment. All right. I don't want the world. I just want your half. All right. So let's write a specification in order to get all the venues in the environment. So I'm going to call this venues in environment. And so this is going to, let me go ahead and turn off Copilot. It doesn't know this yet. So we will disable completion so it's not distracting us. So let's get all the venues in the test environment. This is where we do some things that look very similar to using Entity Framework. We're using a lot of LINQ here. So those skills should translate well here. But given an environment, I want to match. And then the parameters to match are a specification expression. So we've got two different ways that we can have that specification expression. But you can see it always is a function of environment, and then we're going to use this one here that also takes a fact repository. This other one here doesn't take a fact repository, and we'll see what the difference is in a later video. I don't think we'll need that second one for this video. So the environment we will pass in here, and then the fact repository we're just going to call facts. And now inside of here, oops, ba-boom, ba-boom, we want to write an expression using LINQ that is going to get us all of the venues in this particular environment. So we're going to start with from venue in, and now here we use that fact repository, facts of type venue. Okay, so this is similar to an Entity Framework using a DB set. And now you want to limit this where venue dot environment is equal to the environment parameter here. Okay, once you've got those, let's select venue. And that is our specification. This is going to give us all of the venues in this environment. Let's go ahead and run the specification. So we'll get this venues collection. So we're going to await Jinaga client dot query. So I'm going to run a query of venues in environment, and then I can see that the given for that specification has got to be something that matches this given here. So the environment. So I'm going to run that. And now that I've got those venues, let's go ahead and output them. And I can see here we have a list of 2 venues. Both of them are in the environment named test, and we've got 2 different GUIDs. One of them, well, it's not showing the names because I didn't include the names in this specification. So those are the 2 venues I have. I know that I'm supposed to have just one because the Bronco Bowl was deleted. So how do I represent that in the model? I just come in here and say and not facts.any. So there are not any facts of type venue delete, such that delete dot venue is equal to this venue. So there are no delete facts that point back to this venue. And if I do that, then I just get the 1. And that's how deletion works. So you model deletion by using this notfacts.any and exclude those that have those children. All right. Then let's continue this a little bit more. What I really want to see now is the venue name. So let's include the venue name in this list. Right now, I'm just seeing the GUID. That's the only thing I've selected. So instead of selecting venue here, let's select new and create an anonymous object. Oops, there's already one there. All right. So this anonymous object is going to have the venue itself. We'll go ahead and include that. I'm going to capitalize that, so I've got property names in capital letters, as one does in C#. And then I'm also going to get the names. I said names plural. Let's see why. Well, in order to get the names, I have to continue this this pattern. So from name in facts of type venue name, where the name.venue is equal to venue. So I just want the names of this venue. I want to select the name.value. So that's going to give me the string for that particular name fact. Then when I run this, now I see not just the venue with its GUID, but I also see the names, and that's an array of strings. It's always going to be an array. That's because we are using LINQ here to get all of the facts of a particular type, and we're limiting those facts, and it's going to always give us back a collection, never a single value. You might be tempted to do something like this, where you really just want a single value. So anytime somebody wants a single value, you always do the first or defaults. So that seems like a thing to do, but boom, it is unsupported in Jinaga. You cannot say first or default. You have to get the full the full collection. There's a good reason for getting the full collection, which will become a little bit more apparent as we continue. So there we have the venues that are still in my environment, the ones that have not been deleted, and we've got their names. Now, the next thing that I want to do is let's model something that changes names all the time. So in this case, we want to bring in the Starplex. So go ahead and turn on my little friend again. So we want to await a new venue. And then I want to create Starplex name 1. Hey, it knows the history. It knows it was the Starplex Pavilion. Let's see if it knows all the name changes. This is going to be kind of cool. And then I'm going to create look at that. Wow, that is so cool. Okay. Yeah, so the history of renaming the Starplex Pavilion has been recorded in GitHub Copilot. So the name has changed from Starplex Pavilion to the Gexa Energy Pavilion. And let's see if it comes up with name 3. It doesn't, but that's fine. That's fine. It's changed names a bunch of times since then. But let's go ahead and render those facts out and see what that looks like. There we go. Those are the various names that the Starplex has had over time. Now, is that the right way to model that? Which one of these is the current name? I don't know. It's hard to tell. That's because this model doesn't record the causal relationship between them. It doesn't tell us which name replaced which other name. So we need to change the model. We need the model to actually capture that information. One way that you might think to do that, it would be to add a date time, the time that it was changed, and then pick the latest one. There's a big problem with that. The problem is that somebody else might have made a change that you never saw, and then their change just got completely ignored. This is the last writer wins problem. And it is a poor model for a distributed system. We're not going to do that. Instead, what we are going to do is we are going to record the reference to the prior names. So we're going to say venue, in fact, valid from, valid to. That's a really interesting decision, but that's also wrong because we don't know when it's valid to right now. We'll learn that later. So, so we wouldn't be able to change that property later when we finally learn, hey, this is no longer valid, because these things are immutable. The way we're going to represent this instead is venue name array prior. So that is going to capture the list of names that this one is replacing. These are the prior names. Let me save that, come back over here, and we are going to do our run all. Before I run all, let me split this off so that we can change this without changing the identity of Starplex. I'm going to change the name, I'm not going to change the identity. Okay, so let's run all those. And now we can't create this venue name anymore. I understand, we came up with empty. Let's fix this first before we move on. Oh, yeah, all these venue names are broken. Okay, good. Well, now I see the model. Let's go ahead and fix these. So here I'm giving it an empty collection because this is the very first name that I have given it. And then here we're going to give the first name an empty collection. There were no prior names, but then this second one, its prior was Starplex name 1. So now let's run all those things. Okay, let's go back and see how things have progressed. So here's our model. Here is the American Airlines Center venue and the Bronco Bowl venue with the appropriate names. And you can see no other arrows here. These were the very first ones. They just point back to the venue. And then here we deleted the Bronco Bowl. Goodbye, Bronco Bowl. And then here we've created the structure of the venue name Gexa Energy Pavilion replacing the prior Starplex Pavilion. Now we are recording that causal history. And it's easy to see from looking at the graph which name is the current name. It's the one at the bottom. Okay? Now, let's go ahead and change the name a third time. We set the name, we change the name, we're going to change the name again. So we're going to create Starplex name 3. And let's see, the Dos Equis Pavilion, is that accurate? I don't ever remember it being Dos Equis, but let's go with it. That would be the new venue name. Now, Copilot has recommended something that you might think would be necessary. We are recording all of the prior names. That's not actually required. We can instead just have the most recent one. This is the name that this one is replacing. That would be the better way to do it, because then when we render that graph, we can see a chain. So this is the current venue name, it replaces this one, it replaces this one. Okay, so we are building out our model, and we are applying some patterns here in order to keep track of those mutable properties. So I'm going to record a little bit of Yeah, so let's talk a little bit about the what happens if you've got concurrent edits. So I want to record a concurrent edit. Let's suppose that somebody else has come along, and at the same time that we were renaming it to Deseki's Pavilion, somebody else was making a deal. So we'll call this Starplex Name 3A, and we will instead, they wanted to call it the Dos is 2, the Dos Equis Pavilion, XX Pavilion. Yeah, so they got the brand wrong. It's like, oh, I looked at the label, it said XX, that must be it. So that's the name that they want to use. And so they will see this when they look at their graph. They'll say, yep, that's the name of the pavilion. Meanwhile, we will see this one. So it looks like we're seeing two different graphs. Well, the fact is we just haven't shared our facts with one another. So we haven't synced up. Once we do that, then everybody will see everything, and we will see these facts. So I'm going to say Starplex Name 3 and Starplex Name 3A. We'll see everything. And, now I see that this graph has two leaves. There's not just one thing at the end of the chain. It's no longer a chain. It's a graph. So there has been a concurrent edit. Now, when you build an application, you want to be able to show what is the actual name of this venue. You don't know what the actual name of this venue is. These two people made two different decisions with different information, or both of them made those decisions with the same information. They didn't know about each other's information. And so these prior references refer to the information they had at the time that they made that decision. Both of those decisions are equally valid. It doesn't matter which one occurred later in time. Neither one knew about the other. So if you were to just pick one, no matter what mechanism you use to just pick one, you're going to destroy somebody else's information. You're going to completely ignore it without ever seeing it, without ever showing it to the user. And that's just, no matter what that is, that's just the wrong way to do it. The right way to do that is to allow the users to see that this concurrent edit has happened, and then they can fix it. So how are they going to see it? Well, let's go all the way back up to our specification here. And yeah, so here's our specification. Now let's go ahead and run it again, and we can see we've got, we ended up with two different venues. The venues that we're talking about should be American Airlines Center and Starplex Pavilion, Gex Energy Pavilion, Deseki's Pavilion, XX Pavilion, one of those names. So those are the two venues. Bronco Bowl is not in here. Good. But not all of these names are proper candidates. Some of them really have been replaced, and they don't show up at the bottom of the graph. So that means we need to amend this specification in order to exclude those higher level names. So I'm going to say, and there are, you're almost right, Copilot, not any facts. Nay. I should make that work. Nay, no facts of, yeah, that should be the not any, nay. That'd be funny. All right, of venue name. And we're going to say this is the next name. There are not any next names where next dot prior, which is a collection. So where that collection contains name. Okay. So let's think about that for a second. If there was a venue name, we'll call it next, that next prior contains this name, we don't want to hear about it. We don't want to hear about this name. Let's look at this graph again. All the way there. So for this one, does there exist a next whose prior collection contains this one? Yes, it's right here. There's the prior collection. What about this one? Does there exist a next? Yes, two of them, in fact. Both of these satisfy that condition where prior contains this one. What about these two? Nope. Nothing here satisfies that condition. So those are the two that we're interested in. And so when we write the specification like this, then we get just Dos Equis Pavilion and XX Pavilion. So here we have excluded the ones that really have been superseded, and we just have the candidate values, the things at the bottom of the graph, the leaves, if you will. So we present that to the user, and then the user should be able to make a decision. So let's come down here and let's edit that venue. So I'm going to say I want the names in venue, and that's going to be a new specification. So given a venue, match the facts of type venue name, where that venue name is in that venue, and there are no next names. GitHub Copilot was able to just copy that from above and say, yep, that's what you're talking about. Yay, good on you, GitHub Copilot. So now let's go ahead and run it. Starplex names is, let's query names in venue for Starplex, and let's output that. And we see, boom, those are the two names. Perfect. Now the user wants to edit. So they are going to have the desired name, which is Dos Equis Pavilion. So they can see that list of the possible candidates, and so they're going to select the one that they actually want to be the name. When I build a user interface based on this pattern, I'll have a button next to the edit window that indicates, hey, there's a concurrent edit that happened here. Click that button, see the list. You can pick from the list, and then it fills in the edit window. Or if neither one of those is correct, they can go ahead and type in a new one. Whatever they do, you end up with the desired name, and now we want to save that. So we do something like this. If the that collection of names count is not 1, then there has been a concurrent edit and we need to save it no matter what the value is. But suppose that it is 1, so we'll use OR. We'll say Starplex names. Rather than 0, I like to do single, because I already know there's only 1 because I made it past that point of the condition. And so now I look at the value. And so if the value of that single name is not the desired name, or if I need to record anything, record something because I'm resolving a conflict, then I go ahead and record it. I await a new venue name for the venue that I'm editing. I'm going to set the value to the desired name, and then the prior are all of the Starplex names, all of the names that it could have been, to array. Okay, so I'm going to go ahead and run this, and we will see what happens here. Type string, see, desired name is a string. Let's go ahead and make sure that this is Starplex names dot single dot, let's see, Starplex names is a mutable collection of what? Should be, oh, this was an immutable collection of strings. Okay, I don't want the strings. I want the actual names, the actual facts. There we go. So now I've got this collection of facts, and we can see there's Dos Equis, there's XX. And now I can say, given those facts, let's look at the value and see if the value has changed. And if it has, or if you have any number other than 1, then let's go ahead and create a new fact with these particular facts as the predecessors. There we go. That is the pattern that, that you'll be using for modifying a mutable property. So that pattern will become a bit more familiar as you go. You won't have to think about it every single time, but that's the idea. If the count is not 1, just go ahead and record a new fact. You are resolving a conflict. If the count is 1, now you can take a look at the single value that's in that collection and see if it's different from what you want to record. If it's the same, don't bother. But if it's different, record the change. And what that is now going to do is when I take a look at the Starplex names, I just have the 1. It's just Dos Equis Pavilion. I've resolved the conflict. Let's see how that actually looks in the graph. So rather than just showing you those Starplex names, let me do Jinaga client dot render facts Starplex names. Let's show those actual facts to you in the graph. So we had this this history of Starplex Pavilion, Gexa Energy Pavilion, then Dos Equis Pavilion, and somebody made the mistake of XX Pavilion. And then we come along here and we fix the mistake. We fix this concurrent edit and bring the graph back to 1. So now, when we take a look at this this singular fact here at the bottom of the graph, we know that is unambiguously the name of the venue. And so in fact, if I go through here, I'll see that the Starplex name count is 1, it's this one, and the value is the desired name. So if I were to try this edit again, or again, or again, or again, doesn't matter, it's always going to skip that, and we still have the same graph. So that is how we take care of mutable properties. So this is the process of modeling in Jinaga Notebook. You're going to create your facts and render your type diagrams in one notebook, and then you're going to come back and you're going to test out various scenarios in another notebook. And then this is going to help you to get your model right, so that it properly represents the decisions that the user is making inside of their application. And then eventually, the historical model that that you agree to as an organization, all the stakeholders involved, will become a really accurate and detailed historical model that you can implement in code. So on the next, let's see, change that. All right, yeah. On the next state of Jinaga, we will continue with the modeling, and we'll do the same thing with acts. In fact, I'll probably just copy and paste acts so that we can start from there. And we'll go on to shows, and we'll show how we can model the union of two different parts of the application. So stay tuned for that, and I will see you then. Thank you so much.